So this one, we have two solutions. One is 25 milliliters of ethanol, and this one is 150 milliliters of water. And then separate, one solution. Then the second solution is 175 of isopropanol. You know what that is? Let's have a little bit of a organic chemistry thing here. That's ethanol. Ethanol, right? Ethyl alcohol, right? Yes? This looks like this. These are all hydrogens, right? Those are hydrogens. That's the functional group that makes it an alcohol. That's isopropyl, otherwise called 2-propanol. It's on the middle carbon. Okay, that's isopropyl, rubbing alcohol. Depends on where you are. Depends on what they call it. Okay, so this would be, what's the volume? How do I do the volume? Percent by volume. What is it? What do I do? Come on, guys. You can do this. What do I divide it by? By what? Can't hear you.
Volume?
Yes. Volume of what? 150?
Yeah.
Is that right? So, where percent by mass will be the mass of the solute divided by the mass of the solution, percent by volume will be mass of solute over volume of solvent over volume of solute over volume of solvent. Does that make any sense? So do you think it's going to be 25 over 175 or 25 over 150?
75.
Yeah. Remember it said mass, you know, percent by mass is mass of solute divided by mass of solution. Percent by volume, would it make sense then? It would be volume of solute over volume of solution. Yes, that makes sense? Okay, so that would be 175. And what's that going to be? Times 100. So what's 25 over, what is it?
14.3.
I can't hear you.
14.3.
14.3%. Okay, what about this one here? 175 over what? $450? Am I reading that right?
Yeah.
$450? 175 divided by 275. 1 plus 2 is 3, and then 75 and 75 is 150. 3 and 150, right? Right?
38.9.
What is it?
38.9.
38.9% by volume. Correct? Are we all right with that? Yes or no? You all right? All right, can we do the next one right away? No, I want to write it on the board. Oh, no. No. We can do, should I stop? No, let's do a few more. It says, which has a higher boiling point, seawater or distilled water? Now remember what colligative properties are relative to boiling point, right? You've all read this, right? What are colligative properties? Yes, Aiden.
It's a property of a substance that depends upon the amount of solute upon their identity.
Yeah, in other words, if I take plain water, it boils at 100 degrees, right? Okay. And the reason it actually has a low vapor pressure, right? At room temperature, there's a low vapor pressure, right? But I have to heat that so much to 100 degrees because it has such a low vapor pressure. I have to raise the vapor pressure dramatically for it to be the same as the atmospheric pressure, correct? And the reason it has such a low vapor pressure is because the water is held so tightly through hydrogen bonding, as opposed to ether or alcohol, which have lower boiling points, right? Okay, right, now, okay. If I put additional electronic particles in the water, such as sodium and chlorine ions, so not only do you have strength through hydrogen bonding, but now I'm going to put even bigger charges into that water. Do you think that it'll be even harder to boil or easier to boil if I put salt in there? It'll be what? It'll be harder to boil. That's correct. So the boiling point elevates. It's called boiling point elevation. Correct? Yes? So what's going to have a higher boiling point? Distilled water, meaning pure H2O, or seawater? Seawater is going to be. Okay, good. Excellent. So the next one says 1 molar potassium nitrate or 1.5 molar potassium nitrate. What is going to have a higher boiling point? 1.5. Correct. Excellent. How about 0.1 molar potassium chloride or 0.1 molar magnesium chloride? What's going to be higher? 0.1 potassium chloride versus 0.1 potassium chloride. What's going to be higher? Sorry, that's not right. Magnesium chloride. Sorry, just didn't look right there. Obviously. What's going to have a higher boiling point? Same molarity. 0.1 molar or 0.1 molar magnesium chloride. Which one's going to be higher? Same? Could be. Same? Well, who says same? Raise your hand. All right, who says potassium chloride? Raise your hand. All right, we have 1 vote, 2 votes on potassium. How about magnesium chloride? Raise your hand. Nobody. Interesting. Per liter of this stuff, how many particles are going to be in solution? Remember, this ionizes completely. So for every 1 particle of potassium chloride, for every mole, for every 0.1 mole of potassium chloride, how many moles of ions are you going to have? For every 1 mole of this, or for every 0.1 moles of this, how many moles am I going to get? Of ions. Come on, guys, count them. This is potassium plus 1, chlorine minus 1. So how many, for every 1 of potassium chloride, 0.1 moles of potassium chloride, how many moles of ions am I going to get? How many? You're lost. No, you don't understand the question. Lost is not a good word. In other words, look, guys. 1 particle, right, of potassium chloride, right, breaks down to how many ions? 2 ions, right. Right? Yes or no? Let me say it again. For every mole, for every 1 mole of potassium chloride, how many moles of ions are you going to get? 2 moles, right? Yes or no? Okay, good. 1 particle. How many ions are you going to get? 3. There you go. You're going to get Mg, right? Plus 2 chlorines, right? Yes or no? So which one is going to have more particles in it? 0.1 molar magnesium chloride or 0.1 molar potassium chloride? Which one's going to have a higher boiling point? Left or right? There you go. You get it? Higher boiling point. Yes or no? Okay, good. All right. So that was 65. All right, let's quit. Okay? Can we quit? Yay! Hooray! Okay? Do one more? One more? One more? Quit? One more. Okay, we'll do one more. You gotta speak up, man. You gotta speak up.